Hello guys and welcome to my presentation, and today we'll be talking about the life cycle of stars by me. Now, some stars exist for billions of years, but how are they actually born and what happens when a star dies? And now we'll be talking about, first topic we'll be talking about actually is the beginning and end of stars. A star enters the first stage of its life cycle as a ball of gas and dust. Gravity pulls the gas and dust together into a sphere. As the sphere becomes denser, it gets hotter, and the hydrogen changes to helium in a process called nuclear fusion. As stars get older, they lose some of their materials. Stars usually lose their material slowly, but sometimes they can lose material in a big explosion. Either way, when a star dies, much of its material returns to space. In space, some of the material combines with more gas and dust to form new stars. Now we'll be talking about the different types of stars. Stars can be classified by their size, mass, brightness, color, temperature, spectrum, and last but not least, age. Some type of stars include main sequence stars, giants, supergiants, and white dwarf stars. A star can be classified as one type of star early in its life cycle, and then can be classified as another star when it gets older. And now we'll be talking about the main sequence stars. After a star forms, it enters the second and longest stage of its life cycle, known as the main sequence. During this stage, energy is generated in the core of the star as hydrogen atoms fuse into helium atoms. This process releases an enormous amount of energy. The size of a main sequence star will change very little as long as the star has a continuous supply of hydrogen atoms to fuse into helium atoms. Now, the next stage after the main sequence stage we'll be talking about is the giants and supergiants. After the main sequence stage, a star can enter the third stage of its life cycle. In the third stage, a star can become a red giant. Now, you may be asking, what does red giant mean? Red giant actually is a star that expands and cools once it uses all of its hydrogen. Eventually, the loss of hydrogen causes the center of the star to shrink. As the center of the star shrinks, the atmosphere of the star grows very large and cools to form a red giant or a red supergiant. Red giants can be 10 or more times bigger than the sun. Supergiants are at least 100 times bigger than the sun. Now, we'll be talking about the white dwarfs. Now, in the final stages of a star's life cycle, a star that has the same mass as the sun or smaller can be classified as white dwarfs. Now, you may be asking me, what does white dwarfs mean? A white dwarf is a small hot star that is the leftover center of an older star. A white dwarf has no hydrogen left and can no longer generate energy by fusing hydrogen atoms into helium atoms. White dwarfs actually can shine for billions of years before they cool completely. Next topic we'll be talking about is the tool for studying stars. In 1911, a Danish astronomer named Ejnar Herzenberg compared the brightness and temperature of stars on a graph. 2 years later, American astronomer Henry Norris Russell made some similar graphs. Although these astronomers used different data, they had similar results. The combination of their idea is now called the HR diagram. Now, what is the HR diagram? HR diagram is a graph that shows the relationship between a star's surface temperature and absolute magnitude. Over the years, the HR diagram has become a tool for studying the lives of stars. It shows not only how stars are classified by brightness and temperature, but also how stars change over time. Now we'll be reading the HR diagram. The modern HR diagram is shown below. Temperature is given along the bottom of the diagram, and absolute magnitude or brightness is given along the left side. Hot or blue stars are located on the left, and cool red stars are on the right. Bright stars are at the top, and dim stars are at the bottom. The brightest stars are 1,000,000 times brighter than the sun. The dimmest stars are 1/10,000 as bright as the sun. The diagonal pattern on the HR diagram where most stars lie is called main sequence. Now we know what main sequence means. Is the location of the HR diagram where most stars lie. A star spends most of its lifetime in the main sequence. As main sequence stars age, they move up and to the right on the HR diagram to become giants or supergiants, and then down and to the left to become white dwarfs. Now, when stars get old, we will be now talking about three topics, which is the supernova, neutron stars and pulsars, and black holes. First topic to start off with is the supernova. Now, what does supernova mean? Supernova is a gigantic explosion in which a massive star collapses and throws its outer layers into space. Massive stars use their hydrogen much faster than stars like the sun do. As a result, massive stars generate more energy than stars like the sun do and thus are very hot. And compared with other stars, massive stars don't have long lives. At the end of its life, a massive star may explode in a large bright flash called a supernova. And now we know what supernova means. The explosion is so brightful that it can be brighter than an entire galaxy for several days. Next topic to be talking about is the neutron stars and pulsars. Following a supernova, the center of the collapsed star contracts to form a new star. The mass of this new star is about 2 times the mass of the sun. The particles inside the star's core are forced together to form neutrons. A star that has collapsed under gravity to the point at which all of the star's particles are neutrons is called neutron star. So now we know what neutron star means. It's a star that has collapsed under gravity to the point that the electrons and protons have smashed together to form neutrons. If a neutron star is spinning, it is called pulsar. So pulsar now it means it's a rapidly spinning neutron star that emits rapid pulses of radio and optical energy. A pulsar sends out a beam of radiation that sweeps across space. The beam is detected on Earth by radio telescopes as rapid clicks or pulses. Now last but not least, we'll be talking about the black holes. If the center of a collapsed star has a mass that is more than 3 times the mass of the sun, the star may contract further because of the strength of its gravity. The force of the contraction crushes the dense center of the star and leaves a black hole. Now, what does black hole mean? Black hole is an object so massive and dense that even light cannot escape its gravity. Because black holes do not give off light, locating them is difficult. If a star is nearby, some gas or dust from the star will spiral into the black hole and give off X-rays. These X-rays allow astronomers to detect the existence of black holes. And thank you so much for listening to my presentation, and thank you.